Hi, everyone. Welcome to our session, Supporting Access and Equity, Applications of UDL in STEM Learning. We are so glad to be a part of the OSEP Leadership and Project Directors Conference. Before we get started, we wanted to emphasize that my colleagues and I developed the contents of this presentation. These contents do not necessarily represent the policy of the Department of Education, and you should not assume endorsement by the federal government. My name is Jenna Gravel, and I'm joined by my colleagues, Kristin Robinson and Tracey Hall, and we all work at CAST, an educational nonprofit organization focused on a framework for teaching and learning called Universal Design for Learning, or UDL. And at CAST, I'm the Director of Research and Curriculum for Professional Learning. Kristin is a Senior Instructional Designer, and Tracey is a Senior Research Scientist and Instructional Designer.
So as we think about instruction, we at CAST approach it considering what are the potential challenges and barriers for learners. So most STEM learning experiences present some significant barriers for a lot of students in their success, and especially for students with disabilities or other historically marginalized learners. So we take into consideration things such as the decoding, content-specific language and vocabulary, the mathematics that might be a part of their STEM learning, the procedures that they actually need to follow and work through, how to interpret the data that they're collecting, and what is the relevance and the motivation for each individual learner, and is there some cultural connectedness that might be a challenge or a barrier for some students? So we want to think a lot about this fundamental question. How can providing a flexible, supported STEM environment contribute to supporting equity for all students?
And at CAST, we focus on the development of the UDL framework. And this framework is based on 3 principles. The idea of providing multiple means of engagement. So we want to be engaging learners in lots of different ways, providing multiple means of representation. So we're representing content in lots of different ways for learners, and providing multiple means of action and expression. So we're offering learners lots of different ways to share their ideas and share what they know. And additionally, we are addressing the Next Generation Science Standards, or NGSS. And these standards are standards in science to guide the instruction of K-12 education in science.
So we're going to be speaking today about 3 projects. All 3 projects we're sharing were grounded in the NGSS along with Universal Design for Learning and the particular science content within that framework. We are going to take a look at these 3 projects across different grade levels, and they focus on equity in STEM instruction. So the first project is named SNOODLE. We'll tell you what that acronym stands for momentarily, but this project is designed to support students to build sense-making in science at the elementary level. Corgi is the next tool we'll talk about, and it is designed for teaching next-generation science standards practices and cross-cutting concepts, and the focus at this point with Corgi is at the middle school level. And then working with Opportunity Youth, high school and older, there's a tool we call STEMfolio, which promotes STEM skills by building connections between real-life challenges and the next generation science standards. So what we'd like to do now is share examples of how each tool has embedded options and supports for engaging students in the ways that honor unique strengths and experiences that students bring to their learning. We want to represent content, and we're wrestling with those challenges and essential questions and applying learned concepts to the world at large, and expressing and sharing ideas through a range of modalities as opposed to being limited to traditional forms of communication. Now let's address how each of these 3 projects has done this with Universal Design for Learning, and we'll start with SNOODLE.
Hello, everyone. My name is Kristin Robinson, and I'm an instructional designer at CAST, and I'm going to be giving you a tour around a tool that supports elementary students in science sense-making and building science skills, and the tool is called SNOODLE. SNOODLE is a digital science notebook built on the principles of Universal Design for Learning. Focused on the science inquiry process, SNOODLE supports students to build sense-making skills. SNOODLE is more than just a cute name. It's an acronym. It stands for Science Notebook in a Universally Designed for Learning environment. So the first question I think you're probably going to be asking is, does SNOODLE actually level the playing field for science learning? Our data says yes. This graph shows students grouped into 4 quartiles, low, medium, high, and exceptional, based on their pre-test measures of science knowledge. What this data shows is for students in the low and medium groups, when they worked on few or no Snoodle pages, their post-test scores remained low. But the more Snoodle pages students worked on, their scores were more like those of their peers in the high and exceptional groups. So that's what our data says. But what do the teachers say? Well, teachers say, yes, Snoodle levels the playing field for science learning. Some of the comments from our teachers were, students feel like they have the power and control over their learning now. 82% of teachers who have used Snoodle with their students reported increased level of student motivation and engagement. 71% of teachers reported increased student collaboration, which is a key science practice. And 94% of teachers observed a positive impact on struggling students, and that includes students with disabilities and English language learners. Where does Snoodle support equal access to learning? Well, it supports it everywhere. Snoodle provides students with access to information and options for how to represent their skills, their knowledge, and their understanding. And all this is designed in service of building science sense-making skills. UDL supports and scaffolds are available everywhere in Snoodle. Next generation science concept is always with students as they move through Snoodle. Just-in-time vocabulary support to clarify meaning of key terms for each investigation is embedded adjacent to wherever kids are working. Text read aloud with embedded text-to-speech provides alternatives for words and symbols. Translation features provide language alternatives for words and terms. Multiple ways to express understanding are also embedded throughout Snoodle. Students have a choice to write, speak, draw, upload a document or image, and create a table. And they can do any and all of these to answer a question, and it's their choice what mode they want to use to express what they know and understand. There are 6 steps of the inquiry process in Snoodle. Snoodle supports students first by chunking or breaking up the science notebooking process into smaller interconnected steps, making the process of building explanations and sense-making manageable. While the inquiry process can be parsed in many different ways, Snoodle uses 6 steps: question, collect, analyze, explain, connect and reflect, and display. First step of the inquiry process is the focus question. The focus question is the key driver for curiosity, inquiry, discovery, and learning. It orients students to a particular science problem, and it motivates exploration, experimentation, discovery, and learning from data and patterns. A really great focus question can increase students' motivation, willingness to take risks in science, and persistence when challenged. So what are the UDL supports and scaffolds that we can see in Snoodle on this page? Just a few of them are a clear, kid-friendly focus question to engage students and motivate science inquiry and discovery, and a big science idea. This big science idea is there to highlight key ideas and overarching science concepts targeted by the investigation. On the collect page, Snoodle supports students to develop STEM data collection practices by modeling and providing engaging and flexible ways to collect and organize data. Useful scientific data collection is systematic, accurate, precise, detailed, and keeps the focus question at its center. On Snoodle's collect page, just a few of the ways students are supported are the focus question, which has moved to that side space, is prominently displayed. This highlights the key driving question that needs to be addressed by each step of the inquiry process. Use these words. This panel is a list of science vocabulary teachers have identified as essential to know and use in building science knowledge and sense-making skills for this investigation. And finally, sentence starters are also incorporated. We'll see more of those later. Sentence starters support and create the habit for collecting and recording accurate, precise, and detailed data. Analyzing data is the first step in transformation of raw data into meaningful evidence. Analyzing starts the process of making sense of data collected to build and support science explanations. It also guides students to begin to see trends in relation to beginning to formulate an answer to the focus question. And moving from data collection to analysis is a really hard skill to learn and build. And so Snoodle really digs in and supports these practices. So Snoodle's Analyze page is designed to support students to find patterns or trends in the data in relation to the focus question by first making previous work available without losing the flow of thinking and learning. That eye icon provides a pop-up view of a previous page's work, so it's available when students need to access the information. And providing sentence starters and also self-checks in this Did You panel. And both of these areas support analytical skills. The Did You pop-up asks students to self-check responses to assess how they are practicing science skills. Crafting explanations that answer the focus question with a claim, evidence, and reasoning is paramount to building and demonstrating science sense-making skills. On the Snoodle Explain page, students make claims and marshal data to create explanations to answer motivating focus questions. The more they build their explanations, the more they develop science sense-making skills and grow as science learners. In this science inquiry step, Snoodle supports students by first chunking science explanations in a familiar structure, that's CER or Claim, Evidence, and Reasoning sections. And each section has sentence starters and self-checks to guide students' practice of creating a strong claim, citing strong evidence and refuting counterclaims, and elaboration on evidence with reasoned elaboration on how evidence supports the claim that they make to answer the focus question. Snoodle's Collect and Reflect step provides guided options for students to make connections with big science ideas in everyday life and concerns, and what they want to learn more about as science thinkers. And Reflect provides guided options for learners to assess how their thoughts about a science concept, how their strategies, or how they themselves as learners have changed. Most important, research shows that the more often students participate in building explanations and connecting and reflecting on their science growth, the better their science outcomes. As scientists and as teachers, we all know that science findings are most impactful when they are shared with a science community. The display page is the culmination of all the thinking and hard work students have put into each investigation. It's a poster-like presentation of a student's work on the Explain and Reflect pages. The design of the display page emphasizes how a claim, evidence, and reasoning actually connect together to form a whole scientific explanation. And it captures how each individual is connecting and reflecting on science concepts and themselves as learners. Learners have used this culminating page to self-check how well they have explained their science ideas. And this page has been a powerful poster session for teachers to share with parents their students' progress. So let's look back at that fundamental question. How does providing a flexible, supported STEM environment support equity for all students? And let's think about what we just saw in Snoodle. How could you apply the principles used in Snoodle to your own science instruction and practice? And what else do you think needs to be done to build equity in elementary STEM learning? Share your ideas at tinyurl.com/2E59S2Y2.
Hi, everyone. This is Jenna again. I'm going to share a tool that we've been developing at CAST and with our partners at the University of Kansas called Corgi. Corgi is designed for students at the middle school level, although we've been exploring the tool with other grade levels as well. The name Corgi stands for Co-Organize Your Learning, and it also gives us an excuse for a really cute logo. Corgi offers a set of digital graphic organizers with lots of built-in options and accessibility tools that support students to co-organize their learning and engage in discipline-specific practices and habits of mind. And we've built Corgi on Google's platform, so it works with Google Classroom. And best of all, it's free, so you can start using Corgi today. We've designed Corgi to engage students in a step-by-step process to break down and make meaning of complex ideas, making content more accessible to students with and without disabilities. And so far, we've built 4 different digital graphic organizers: cause and effect, compare and contrast, question exploration, claim evidence reasoning, and we're also working on more to come. And the design of Corgi is guided by the 3 principles of Universal Design for Learning, or UDL. To embed multiple means of engagement, Corgi offers real-time collaboration, so learners can be working together and collaborating. Corgi also offers teacher-embedded instruction and a customizable layout, so students can kind of organize the layout according to their preferences. To embed multiple means of representation, Corgi offers video instruction, text-to-speech, a dictionary, and a Spanish translation feature. And to embed multiple means of action and expression, Corgi offers students lots of different ways to share their ideas. They can respond through text, through speech to text, through images, and through video. Corgi also offers progress self-checks and a Google Slides export feature. So I wanted to take you to the tool to show you how these features are embedded right into the learning environment. So this is our cause and effect graphic organizer. At the top of the screen is Corgi's text help toolbar. The toolbar lets you highlight any text on the screen and have it read aloud to you. You can also highlight any word and look it up in the built-in dictionary or translate it into Spanish with the translation tool. The panel on the left shows the different steps of the guide as students engage with a cause and effect relationship. And the panel on the right shows the full guide as it's being completed. And this is a way to offer learners kind of the big picture. And this view can be closed and customized depending on your preference. So if I click on the first step of the cause and effect guide, I'm prompted to enter the essential question. And with this example, the teacher has actually embedded some specific instructions for their students to explore before they even enter the essential question. So I'm prompted first to enter a title. For this example, students are engaged in a unit called Seasons on Earth. And I'm also prompted to enter the essential question: how does the tilt of the Earth's axis cause our seasons? And I can enter this essential question by typing or through speech to text. And I can also insert an image to represent the essential question. So the Corgi Cause and Effect Guide continues to guide learners through a series of steps to explore a cause and effect relationship. And by the end of this step-by-step process, students have explored the essential question, the key terms, the causes, main event, and effects, and created a summary to synthesize their learning. And students also have a range of ways to share their learning. They can create a Google slide presentation, they can share the actual guide, they can print the guide or save it to a PDF, or they can post the guide to Google Classroom. So we hope this little tour has inspired you to give Corgi a try. You can visit corgi.cast.org, or this QR code will take you right there and you can jump right in. And I also invite you to reflect on some key questions and share your ideas about Corgi. First, how might you use Corgi in your own context? And second, what else do you think needs to be done to build equity for learners to engage in discipline-specific practices? So you can share your thoughts by accessing a Google Doc. The link is tinyurl.com/2E59S2Y2. And we'd love to learn from your ideas.
Hello, I'm Tracey Hall, and I'm here to talk to you today about STEMfolio. This is a tool we've created at CAST for opportunity youth, and that is students that are 16 to 24 years old who generally have not graduated from high school and are unemployed. So how does STEMfolio promote STEM skills? Basically, there are 4 components to the STEMfolio tool. It has built-in scaffolds and supports, all based on the framework of Universal Design for Learning. It has an e-portfolio to collect evidence of STEM learning and competency building that young people are doing as a part of their programs to enrich their lives. There are video case stories available for near-peer role models who are engaged in STEM careers. And we finally have rubrics to help staff in evaluating students and students in their understanding and applications of STEM skills and knowledge. The STEM folio is a way in which we are really wanting to help break this cycle of systemic economic inequality that women, communities of color, the working class, and the working poor are disproportionately facing. STEM folio provides a means by which students are more readily available to demonstrate their understanding, work on their organizational skills, and illustrate their accomplishments in their learning of STEM skills and career skills. To begin with, the tool overall has some accessibility utilities. In other words, they're global. They're available throughout the tool. We use the text help toolbar to help students read aloud the text that's on the screen. That is text that's written by us as programmers, by their instructors and themselves. There is also a dictionary that the students can use to look up words. We have translation available, and they can have settings to adjust volume as well as speed of the text that's being read aloud. Also, we have speech to text available, which is a voice input for all of the text fields, and students on mobile and desktop devices with mics can speak the words that they want to say, and they will be dictated on the screen for the young person. As I mentioned, there is a lot of video available for students to view, for teachers to use, and there's closed captioning on all videos, which includes subtitles in English, and then there are audio translations available for other languages as well. In an overview of the tool, we have 5 basic parts: the challenges themselves that are assigned by their instructors, the completed challenges that the student has finished or has attempted and put forward. There is a place in the student teacher side of this tool to see student work across classes, across particular challenges, or for an individual student. And there's the folio, and we'll talk in more detail about that in a moment. That folio is something that can be organized and shared by the individual learners. And then finally, those resources, most of which are in the area of video. So let's look at what a challenge is. The challenge is basically a 3-step process by which a student is given a prompt or a question by their instructor or teacher. And in that prompt or question, we've limited the amount of text that the teacher uses, and the teacher can also upload images or video to help set the stage for the challenge that they're creating for their students. We really want to highlight that real-world application of skills that students are learning in their work and facilitate that connection between what it is that they're doing on the job and the alignment to the competencies that they're working toward in STEM. There are a variety of media types available in that the directions can be read out loud and so forth. There are multimodal responses. As we mentioned a moment ago, students can use video, photo, or upload, and that's all done in step 2. And then finally, there's a step 3, which is competency tagging, and that's taking those competencies that the teacher has selected from a whole series of competencies, and the youth or the learner then selects 3 of those competencies that best describe how they responded to the challenge, the competencies they addressed as they responded to the challenge. The learner can post that challenge, and that will go into their file, and the teacher can see it as well, or they can cancel it and redo it if they choose. Student work is seen by the teacher in a number of ways. The teachers can filter by class, by student, by specific challenge, by type of challenge, whether it's in STEM or in the career skills. And again, the accessibility and the supports are there. There's also supports that are a little different from what I mentioned earlier, and that is a learner can line up their competency or their challenges that they've created and look at change over time and growth over time. The teacher also has an opportunity to provide feedback in a comment section to all of the challenges, and students can edit or rework their challenge if they choose using that feedback. The competencies, as we mentioned, we currently have 32 in the STEM folio version of this eFolio tool. And these are competencies that are based on the next generation science standards and career skills that young people really need to succeed on the job. And these competencies have been stated in a first person I can type of a style, in which if the learner is not familiar with the term that the competency is listed as, they can click on that little I button and see the definition in fairly straightforward language of what that competency is addressing. Here is the space in which students can access, and teachers also can access, the videos that are available. And these videos have been created here at CAST, and they are really a collection of videos that are about 2 to 3 minutes in length. We really focused on getting near peer folks reflecting on their learning, reflecting on the jobs that they selected and the career pathway that they've chosen. Administrators have also contributed to this from different schools and training facilities. CEOs have also shared for what they're looking for in prospective employees. So there are really a range of videos that are available for students to get some information and kind of learn for themselves. They have lots of options to connect their interests, readiness, and skills towards those STEM career pathways. Oftentimes, these videos have been used by teachers as inspiration for the challenges that they're putting forward, and students have used those videos as an illustration of how they've made a connection to a particular challenge and the work that they're doing. Here is the folio of STEM Folio. This is a space in which students can take those challenges that they've completed and organize them in a fashion, select from all of the challenges that they've done for a specific purpose. And that purpose might be a folio to share with a prospective employer, a folio for application to a school. That's kind of what's been put together here. This is a series of challenges that this student has completed as they're putting a package together to go to a vocational skill or apply to a vocational skill. So they can put in their challenge responses. This is also a space with the challenges in which they can save things like certifications and licensures. So those are all put into that package, and the reviewers of that package can see a range of ways in which the student is building their skills and competencies. If you're interested in STEM Folio, here's a way to get more information. You can contact us at CAST by emailing stemfolio@cast.org. Finally, we'd like to ask you a fundamental question. How does providing a flexible, supported STEM environment support equity for all students? Think about that in relation to your work, into the things that you're doing with young people. How could you apply the principles that were used in this STEM Folio application to your coursework and instruction? You may or may not have a mobile device, but there are many things done here that can be applied in other ways. And what else do you think needs to be done to build equity in STEM and career pathway learning? You can share your ideas on that page that you've been going to previously. That's at https://tinyurl.com/2E59S2Y2. Thank you for your time and attention.
Thank you for viewing our presentation, Supporting Access and Equity, Applications of UDL in STEM Learning. If you would like to learn more about the STEM projects highlighted here, please visit the session handout for links and more information. If you would like to learn more about CAST, please visit our website at cast.org. This content was developed under a grant from the U.S. Department of Education. However, the contents do not necessarily represent the policy of the U.S. Department of Education, and you should not assume endorsement by the federal government. The contents of this presentation were developed by the presenters for the 2022 OSEP conference. However, these contents do not necessarily represent the policy of the Department of Education, and you should not assume endorsement by the federal government.